So for this video, we're going to be graphing a rational function, y equals x squared minus 4 over 2x. So we're going to use these tools in order to help us graph it. So first, why don't we find the x-intercepts of this function. X-intercepts of this function occur when y equals 0. So multiply both sides by 2x, add 4 to both sides, take the plus or minus square roots of both sides, and you get the x-intercepts of 2, 0 and negative 2, 0. So now we're going to find out the domain of this function. So we know that this function exists everywhere, or is defined everywhere, except where the denominator is equal to 0. So let's find where it's not defined. So we're going to set 2x equal to 0. So we'll find that x equals 0. So the domain of this function is from negative infinity to 0, union 0 to positive infinity. So now we're going to take the derivative in order to find the critical point, so we can see where this function is going to be increasing or decreasing. So y prime is going to be equal to 2x times 2x minus the quantity of 2 times x squared minus 4 over 2x quantity squared. So then that becomes 4x squared minus 2x squared plus 8 over 4x squared, which equals 2x squared plus 8 over 4x squared. Further simplified becomes x squared plus 4 over 2x squared. So this is going to be our derivative. So in order to find our critical points, we find where this derivative is 0 or undefined. So we're going to plug in 0. We're going to set the denominator and the numerator equal to 0. We'll find that this gives us an x value of 0. And this gives us an imaginary number. So we're not going to deal with this one, because we don't deal with imaginary numbers in calculus. So we have our critical point of 0, and we're going to make a sign chart of the derivative. If we plug in any number less than 0, we are always going to get a positive value back. And if we plug in any number greater than 0, we're going to get a positive value back. So this means that y is always increasing. So then we're going to come, and since we know that y is not defined at 0, we're going to see if we're going to have some asymptotes at 0. So I'm going to take the limit as x approaches 0 from the right of x squared minus 4 over 2x. And I'm going to take the limit as x approaches 0 from the left of y, which is x squared minus 4 over 2x. And so for here, we're going to get negative infinity, and here we're going to get positive infinity. So the last thing we have to find is where it's concave up, concave down. So we're going to take the second derivative. So here's our first derivative, and we're going to be taking the derivative of that. So this derivative is going to be equal to 2x times 2x squared minus 4x times x squared plus 4 all over 2x squared quantity squared. So this becomes 4x cubed minus 4x cubed minus 4x over 4x to the 4th, which becomes negative 16x. I'm sorry, this was supposed to be negative 16x. I apologize. So here we're going to be equal, so the 4x cubes cancel out. So we're going to have negative 16x over 4x to the 4th, which is really equal to negative 4 over x cubed. So this is going to be our second derivative. Now in order to find where this function is concave up and concave down, we set the second derivative equal to 0. So negative 4 is never going to be 0, so then we plug in the denominator. So 0 equals x cubed. So 0 is equal to x. So now we can plug in our sign chart for the second derivative. If you plug in any number less than 0, you're going to get positive. So that means I'm just going to draw a little symbol for concave up. It's going to be upwards bowl. And then if you plug in any number greater than 0, you're always going to get a negative number. So this is going to be negative, concave, down. So here we have all the tools that we'll need to graph this function. So I'm just going to write them right here so we can have a reference when I erase the board. Negative infinity, comma 0, union 0, positive infinity. We're going to have 2, 0, and negative 2, 0. We're going to have our asymptote at 0. We're going to have these intervals of concave up and concave down. And we're going to have our intervals of increasing. So let's graph it. So we're going to have our axes. Going to make this 2. This is negative 2. So we know that at 0, this function is not defined. We know that it is always increasing. And we know that it passes through the points negative 2, comma, negative 2, and 2. So if it's always, so concave up, well, we're first going to be concave up. Then we're going to be concave down. We're going to be increasing and increasing. So concave up is going to look something like this. Oh, gotta go through the point. Going to be this side of the graph. And then the other half of the graph is going to be concave down and increasing as well. And so that is our graph of y equals x squared minus 4 over 2x.